when I have free time, when I'm relaxing, I'm coding, because coding for me is relaxing.
Today's guest is one of the true leaders in our field, Dr. Qiusheng Wu. If you've ever used Leafmap, GeoAI, or his tutorials on YouTube, you already know his impact. And now he's launched a new book on Python for Geospatial, one of the most complete resources in our space.
So this goal is to simplify the process, because for people that without program background, it can be quite challenging to, like, if you have 100 lines of code just to visualize a raster on interactive map, it's kind of a little bit intimidating.
In this episode, we dive into some of the toughest and most exciting questions shaping the future of geospatial. How to choose between Python and SQL in modern workflows, what the rise of embeddings and foundation models means for GIS, and how open source education is transforming opportunities for learners everywhere.
The more important thing I want to convey is that not about a particular package, it's more about the critical thinking. How do you subdivide a task into smaller pieces?
We also talk about how Dr. Wu balances building tools, teaching, writing, and publishing at an incredible pace, and the philosophy that drives his work.
You don't really need a college degree to do this stuff. If you really have some time and then you have patience, anyone can learn.
This is a conversation about technology, education, and the future of geospatial, and I can't wait for you to hear it. The future is spatial, so let's get into it. Okay, Dr. Wu, welcome, and thanks for being here. I think you probably need no introduction, but why don't for those who don't know you, why don't you give us a kind of a quick intro on who you are and what you do?
Yeah, of course. Thanks for the invitation, Matt. And I'm Qiusheng Wu. I'm an associate professor at the University of Tennessee, and I do open source geospatial education and also development. And yeah, that's about me.
Nice. Well, yeah, I think one big thing you've done recently that I want to kind of jump right in was to talk about your new book. Just I think like past month or month and a half, you put out a very in-depth, very full, complete book all about Python spatial. And I think, of course, while there have been different books about using Python in different ways in lots of different formats and libraries, I think you took on like the monumental task of really going into all the possible use cases across all the different libraries, and including the libraries that you built over time. So I wanted to dive into that, kind of talk a little bit about the book, kind of what's in there, and why it's important to have kind of this complete, roadmap for learning all these different pieces of Python.
Yeah, so basically, it's kind of a book that stem from the course that I'm teaching here at the University of Tennessee. So I have been teaching the introduction to GIS programming, I think, since I joined the university in 2019. And so during the last couple of years, the content has changed so much, because initially I'm teaching something that other people have taught, but slowly during the last couple of years, I've developed some open source packages. And also I have learned a lot more about open source geospatial. So in the last 2 years, I kind of totally transformed the content to teaching just focus on open source geospatial. And I have all those code examples and all the tutorial online and also YouTube. And I was thinking maybe I can just put it as a book, because I already have the content. I just need to write the description, have all the figures and also the images. So, and during the summer, the last couple months, I spent a lot of time trying to basically think about how I want to teach it. And so I kind of review all the example they already have, and then trying to present in a logical way that people can learn from beginning. For people that don't have any program background, and then start from the very beginning, and then slowly progress to more advanced geospatial analysis and visualization. And it's kind of just each chapter covering some open source packages. Of course, at the beginning, also cover some software setup and also some Python fundamentals, but the focus will be on open source geospatial, so covering a lot of most popular open source packages to do geo visualization and also analysis. And actually, I wanted to have more content in there, but at the end, it's only like 500 and I think 60 pages. I was thinking I should have another section about like practical applications. That how do you combine all the open source packages all together to do some real world projects? Although in some of the chapter already, I mean, have covered. It's not each chapter, although it's about a particular package, but in there already use a couple other more like introduced in the book. So, but there might be the next edition might be have another book just focus on real world applications using those open source for geospatial analytics and visualization. Yeah, and it's all self-published. I don't have any editor. I just all by myself, just put things together, and I also learn how to basically compile. Write the book using Markdown and then compile it as a PDF using types, TYPST. It's kind of a new tool for creating interactive content, also PDF. It's pretty nice. And then just put it on Leafmap and also Amazon. It took a while for me to actually go through all the approval, but yeah, I think it turned out pretty well. The quality was, I think the printing quality was decent. Yeah.
Yeah, I mean, it's not just like the writing of it, you know. I mean, compiling all the content, but you have code examples, you have, like just translating from like Markdown into an actual PDF in a book. And there's so much work that goes behind all those different pieces. So it's kind of like, like I saw it and I was like, oh my gosh, I know how much work goes into that. And it's like, it's really impressive to see it all like come together and go from there. What, how do you kind of see people as they come into like open geospatial or Python? I think one of the trickier things is like kind of guiding that journey on like, okay, which libraries do I choose? How do I use them together? Because there are a lot of choices out there. You have some of your big things like, your GeoPandas and your Rasterio, and you start to get into, more specific packages. If you want to do spatial stats, there's PySol. If you want to do distributed processing, or scale up the data, you have Sedona and DuckDB, and you have all these different options. How do you kind of, weave those together, and help kind of, one big thing I see, and I don't know if you see this too, is kind of helping make the choice for like the right pieces of the puzzle, depending on the problem to solve, because there are a lot of choices. How do you like kind of help guide people through that when they're making those decisions?
Yeah, those are mostly based on some of my previous experiences, how to use these packages. And so in the book, I try to basically present some of the common applications. If you want to do visualization, you can use this, you can use that. If you want to do different application, for example, sometimes you use DuckDB, but sometimes you use Sedona. It depends on the kind of application. And in the book, I do have some like best practices. For example, when do you use, for example, Python dictionary? When do you use the list? When do you use the tuple or something like that? So I think it's very important at the beginning to teach more like slowly deal with handling different applications. And then one thing I like about open source geospatial is that we have a lot of choices, and people can choose whatever they want. But I mean, without program background, it can be quite challenging to like, if you have hundreds of lines of code just to visualize a raster on interactive map, it's kind of a little bit intimidating, right? So why not like we have just one line of code, you create a map and then just add the raster, add the vector. So it'll be so much easier. Even for myself, like I know how challenging it is to learn all the concepts and how to put things all together. So if we can simplify the process, more people use it, and also try to make it easier for people to publish the content. So for example, after you generate this, how do you put it online? The other people can try it out so that you don't have to start everything from scratch. Yeah, it's something that I kind of try to simplify the future self, me learning this process, try to make it easier for myself, but also in the meantime, if this makes it easier for other people, that's great.
Yeah, it's one thing that I found is like you can figure out how the pieces of the puzzle fit together, but like kind of like you said, is like understanding those underlying data structures, those little choices, that you make early on between data types and even structuring your files or things like that can make a world of difference down the line in terms of how you consume those things. And especially when you're working with like outside data that like, you have a nested, how do you deal with like a nested data structure in this new system that you've never worked with before? If you know nested data structures, you can start to piece, together. And that's where you get some of those, like, you can really become independent in these tools. What, like I know Leafmap is really has a lot of pieces to the puzzle. One thing that I really like, and I spent a lot of time building custom applications and visualizations and sliders and stuff all
Mhm.
in JavaScript and using React and all the stuff like that. Um, how much like what have you heard from people that use that package, and how much easier has it made them to kind of like get their work out there? Because that was one hurdle that just took
Mhm.
was creating apps to like actually interact with the data, specifically like raster data. But like, how are people using that package, and like what's kind of been the impact from that?
Yeah, I think people, I mean, from time to time, I get some email from people that saying, "Oh, I use the package, it's great," but I actually don't know all the kind of real world application they're using. And from time to time, also people, I mean, if they run into issue, they open a GitHub, and but I think some of people are using it for teaching at the university settings, and also used by some of the federal agencies, for example, NASA, also used to be by Microsoft, but um, it all depends on what people need. So, I mean, there are a lot of ways of doing the same thing. I think Leafmap is kind of simplify the whole process that just a couple lines code. Of course, I'm not a professional programmer. I just like, okay, I want to do this task. It's not so easy. I just want to simplify it and then integrate into the Leafmap. So I try to add functionality pretty much every week, if not like every day. So if I'm working on a project for something on something, and um, if it's not available or is it very difficult, I will try to find a way to simplify. And so at the end of the day, all the things that I want to do is just maybe one line of code or even no coding. Once you have the map, you should be able to actually interact with the map and visualize all kind of geospatial data. So this kind of my goal. But yeah, it can pretty much do any type of data visualization. It's focused on visualization, but although it has some like basic functionality for doing analyzing the data, process the data, but um, there are also other packages. For example, GeoAI can do some of the tasks for doing like machine learning and also AI. But I try not to make it too big, because at the end, if you want people to adopt it, it needs to be easier to install. So the more functionality you have, the more likely they're going to have a lot of dependencies. It's
Mm.
going to make it a little bit more difficult to install. So my goal is to keep it simple, but also make it powerful.
Yeah,
Mm-hmm.
I mean, it kind of feels like, I mean, when I first discovered like how to use React properly,
Mm-hmm.
like instead of I could write one component,
Mm-hmm.
use it over and over and over and over again, and I could spend a lot of time building that one component, be it
Mm-hmm.
slider, a date picker, whatever it was, and just reuse it consistently over. And that's kind
Mm-hmm.
of what it felt like, for instead of building like matplotlib charts that aren't
Yeah.
interactive at all, and you have to add all your labels and stuff like that. Now it's just like you said, boil it down to one line of code. You can go and you
Mm-hmm.
can move very quickly. So that's what I've loved about it, is just the
Mm-hmm.
ability to move really fast and go from that perspective.
Mm-hmm.
Um, I want to talk a little bit about some of the AI stuff a little
Mm-hmm.
later, and kind of seeing what you built into GeoAI, and
Mm-hmm.
also talk a little bit about embeddings. But I did want to kind of talk about, because I know the book and the things that you've put out there in YouTube and different places interchange Python and SQL quite a bit.
Mm-hmm.
And kind of I use both in my day to day. I'm sure you use both as well.
Mm-hmm.
How do you kind of, this is a question I get asked a lot. I don't know if you get asked it the
Mm-hmm.
same. Kind of how do you choose between Python and SQL? Is there like one versus the other? How do you intermingle them?
Mm-hmm.
What's your take on that?
Yeah, so for me, I mean, I use them both, like just like you. And Python, I think use Python more than SQL, because I do a lot of data visualization. So if you want data visualization, I mean, Python is certainly the way to go. SQL doesn't really have, it's more like data querying from the database. So it's not really suitable for doing mapping and geo visualization. And also, if you just want some simple automation, or if you just want to have some task they're going to run every day, every hour, then probably Python is the way to go. And also you have a lot of choices, like there are a lot of packages out there, you can do all kind of tasks. And but if you want to do larger scale geospatial analytics, I mean, SQL is still the way to go. Python is not very efficient, and they cannot handle like large amount of data. So you need to maybe have some SQL knowledge to use, for example, DuckDB or PostgreSQL or Apache Sedona to basically do large scale aggregation or doing some analytics. So, and I mean, if you know how to use those, it's going to, I mean, save you a lot of time, because traditionally, if you're handling like 10, 20 gigabyte of geospatial vector data, if you use Python, like using GeoPanda, it's not very efficient. It's going to take you a while to actually handle that. So with DuckDB and Sedona, you can query, for example, let's say Overture or Maps data, like building 200 gigabyte global scale. You can query that, you can get the data you want, you can aggregate, so you can do those things pretty quickly. So I would highly recommend, I mean, for users that don't have any programming background, you might want to start with Python. And then slowly, once you get to do more and more data processing, then you can use Python to basically, for example, use DuckDB, but you can use Python to call DuckDB functions to query the data. So I think combine those two, you can do a lot of things. So you can do analytics using DuckDB, and then you can use Python to do some mapping. So once you get the result out from the database, then you can do the mapping or do the visualization using Python.
Yeah, I mean, I definitely feel the same way. I mean, like a lot of the heavy data work, which is really broad term, if you have to. But when I want to do a big spatial join, if I want to do really heavy zonal stats, even if I want to do some sort of kind of processing or something like that, I usually go to SQL, and I do it there rather than doing it in like just kind of like a data frame. If you need to do something simple in a data frame, sure. And don't get me wrong, everything that's happening with GeoPandas, a lot of the stuff from things like GeoArrow are really exciting because it's going to speed all those libraries up quite a bit upstream. But that's kind of where I find it, where I do quite a bit of stuff in SQL, where there's that heavy processing, translating, kind of finding KNN joins, stuff like that. That just it's a little bit easier. There's obviously optimizations and data structures you can add to the database or the system for spatial indices or sorting or anything like that. But then Python, I think it probably covers a wider swath of things. Like you said, there's of course automation, scripting. It lets you kind of tell the program what to do, or the notebook or whatever that is. Visualization, I don't think there's really any visualization in SQL apart from like you can do some tiling in some SQL systems, but that's literally it. And then I think statistical, like kind of logic as well, like things like PySal or machine learning or stuff like that are well suited for Python because it has some of those kind of just tools and libraries built into it. So I tend to agree as that's kind of the way you want to try to split this up. I think a SQL workflow where you build the structure of what you want to accomplish, a Python workflow where you build that structure and then adding in SQL strategically for the heavy things that are taking too long to run is probably the way to go. And there's a lot of different cases for that, but that's usually how I kind of interchange it quite a bit is those two different ways. I mean, how do you kind of use that on a day-to-day, like when you're kind of interchanging the two? What are like the most common tasks you hand off to SQL, for different use cases?
Yeah, so something like data aggregation, spatial noise. So if you, for example, work on a lot of like, let's say building data. So if you want to like query the data for a particular area, then for example, from Overture maps, then SQL and DuckDB probably is the most, easier to get started. You can use, so overall as a rule of thumb, like if your data is only like maybe 10, 20 megabyte or less than 100 megabyte, you can just use GeoPandas to do all the data processing, retrieve the data. But when you get to like gigabyte or hundreds gigabyte data, then definitely SQL would be much better choice. So for me, I use DuckDB to easily query the data, aggregate the data, and then you can get a subset of the data that you want. But if you want really some scalable solutions, then Sedona would be much better, but it needs more hardware. So you do need to have a better computer, or you need to use some cloud computing resources to help you set up those clusters. But for like consumer level use applications, then I would recommend people just use DuckDB because it's much smaller to install, and also you can run it on any computer that you can use Python. So it's pretty easy that nowadays you can just use a browser, you can use Google Colab, it's already have DuckDB pre-installed, so you can easily use those to query all kind of open data, for example, in AWS or whatever third-party data providers. And it's very powerful because traditionally that can take hours for you to actually load the data, and even you can download the data stored on a computer. You won't be able to actually do anything because it may be stored in a geo database or in large geo packet, but if you don't have DuckDB, it's going to take you a while for you to read that using GeoPandas if the file size is like hundreds or tens of gigabytes.
Yeah. And there's a lot of like there's still a few cases that I'm like trying to see what will get shaken out. Like things that I still find hard are like creating routes. Like, your routing is great, but PostGIS can be tricky to set up, but like it can, most routing is solved via an API. Even like OSR is all route based. Just like, kind of distributed raster processing. Like raster is, I like, this better than me, but I think there's so much dependency on like adding GPUs or like some of those things to especially scale that out. And that's one thing I want to talk a little bit about. I think there's different things that they're starting to help with that. Of course, the leaving data on the cloud native can filter and just pull in what you. So look, all those are good things, and that's going to make a big shift. But even then how do we process that at scale for the pieces you do need? Those are and then things like geocoding are still like all very like one-to-one transactional based. Like it's there's I want to see those things kind of start to get distributed or handled in some way differently. And they're still setting up a geocoding system locally is a monumental task because how do you even start to accomplish that is very difficult. But talking a little bit about kind of moving into some of the raster processing and things like that. By the time we're recording, I think it was like last week, there was some big announcements around embeddings. From Google, they announced that, and there's a lot of people working on this problem. And there's a ton of interest in it because it looks really cool. I think there's also been like I just in terms of the flurry of information out there, and I'm sure you're reading the same things I am on LinkedIn. Is this the Chat GPT for the Earth? What does this really mean? What's your like perspective on embeddings? And how do you see them being used? Have you played around with them? What are your thoughts on that kind of whole these developments have been taking place?
Yeah, certainly. These kind of things are very, hot topic right now in geospatial. So related to geospatial foundation models, how can we develop this kind of model that can be useful for lots of downstream applications? So the AlphaEarth foundation model released by Google and DeepMind, I think 2 weeks ago, it's kind of a groundbreaking and very, very powerful. And so I did play with the data and try to make it easy for people to visualize, look at embedding. But for those who are not, in AI and geospatial, so embedding basically just a compact numerical representation of the information from the raw data. So basically they train the model on, I think, a couple billion, 3 billion images, like Landsat, Sentinel, and then eventually they generate this kind of embedding at 10-meter resolution annual embedding. So from 2017 all the way to 2024. So we have 8 years of data. So you can think about 8 global imagery at 10-meter resolution and embedding. So for each year, it has 64 embeddings, so 64 layers. So you can think about it's just numbers. So it's kind of an abstract representation of information that captured by the satellite data. And similar to some of the machine learning or algorithm, for example, kind of like principal component analysis, that you can reduce a large amount of data into something smaller, compact, represent something, but we don't know what it is. So kind of like a black box. But I can use this one to do a lot of downstream application, for example, using unsupervised classification, for example, clustering, or you can do supervised classification, or you can do change detection. You can do a lot of other applications utilize just the embeddings. So for example, if let's say we have global land cover data products, developed by, some of the popular products, for example, by ESA, European Space Agency, the global lane cover from 2020, 2021, right? But it would be nice that we can develop lane cover data every year or every month, right? We can have more frequent. So I think the embedding is very powerful for this kind of application, that within that time frame, if the data that you're using is within 2017 to 2024, then you might want to try it out, because basically the spatial temporal context is already captured in those embeddings, and you can use that to easily generate something, because for the embedding is like spatial and temporally consistent. That means if the number, they are very much similar in that vector, so we have 64 layers. So for each pixel, you have 64 values. So if the locations on Earth that are generate very much similar vector, that means they might be belong to the same category. So you can use that to do, link cover classifications using just the embedding without having to train your own model. So you can use the embedding to generate link cover classification easy, or you can use to change detection using the dot products. So it's pretty powerful. But one thing you need to keep in mind, the data set is huge. So I actually tried to play with the data, trying to download the data from Google Earth Engine. It took forever. And for each tile, I think it's around like 180 to by 180 kilometer, or 160, I forgot the exact number. So it's 10-meter resolution, and the uncompressed file size is about 80 gigabyte. So if you're trying to download it to your computer, it's not going to work. It's very difficult to get the data out. So you better just try it out using Google Engine, either JavaScript or Python, and then you can apply to run computation on whatever application that you are interested in.
So there are a few things I think you hit on that I've heard about some of the embeddings. I think one thing that they're really good at is like kind of similarity, like you said, clustering, finding things that look like each other, stuff like that. And then on the flip side, also change, like you can understand those things. I think they're really like, it sounds to me like very broad topics. Like you can't like kind of hone in on, is this asking questions, is this the right area to do this specific application? Or, can you detect these things for me and stuff like that? They have these very kind of big questions that you can answer from an Earth level. And then you have the other extra challenge of, okay, they're massive files. How do you start to work with them and process them at that scale? So it feels to me like we're kind of at this place where you have two different ends of the spectrum of like this, where you can do really big stuff, with, at a very high like resolution. You can ask big questions like similarity or time change and stuff like that. And on the flip side, you're going all the way down to the lowest level, asking, very specific things like, can you, identify these objects in this image? Can you, find, these types of land classifications and start to group things on a very granular level? Can you tell me, all these different things from like a, more of the image detection side and stuff like that? Feels like we're kind of like, there's this big gap in the middle of how do we bring those two things together in some way, and that seems like there's still a long ways off. And I know from your like GeoAI package, some of the work that's happening with, some of the generic kind of like image recognition models like SAM2 and OWL and stuff like that. I think there's a lot left to do there. And my kind of perspective, and I'm curious your thoughts on this, is like, I feel like there's still a lot of room for people building and developing their own models for very specific applications. And as these things start to develop over time, there might be some convergence. I don't know how much, but I still think there's a ton of application for actually learning how to build models and developing themselves, and then using some of these different tools to do some of the more granular work. But what are your thoughts on that?
Yeah, I certainly agree with you. There's some gap in there. This kind of a foundation model is very powerful if you want some common like general applications, link cover, clustering, similarity, search, but it has its limitations. Just like ChatGPT, right? It's trained on the data that it has seen or it has used. So there's a time if you're trying to use it for some more like near real time, it's not going to work, because the data was trained on Sentinel-2, Sentinel-1, and also Lancet data from 2017 to 2024. So if you're trying to do like 2025, you need to find other ways to do it. So you cannot directly use it, or if you want to study something happened in the 1980s, 1990s, the information is not captured there. So maybe in the future they will release maybe some earlier embeddings for data before 2017. I'm not quite sure because it does need a lot of data. So in the last 10 years, we have more satellite missions, we have more data available. So it's kind of a focus on those years they have more data. But if you want to do lane cover classification for 2025, or if you're trying to do some disaster mapping, for example, or disaster damage assessment that just happened a week or months ago, it's not going to work very well because the information is not captured there. Just like when you ask ChatGPT, okay, although right now it has the internet search capability, but without it, you won't be able to actually find the near real-time information. So I think that's one limitation. That still we will need some more specific trained machine learning models if you want to detect objects from imagery that were acquired more recently. So that's one. It's the temporal kind of a resolution. The other one is the spatial resolution. The data is a 10-meter resolution. So we're trying to detect objects that much smaller than 10 meter, for example, say building detection or other stuff. It's not going to work because it's the resolution is not high enough. So for building, you need using meter sub-meter level resolution able to be able to do that. So for smaller object, it cannot handle very well, and also it doesn't capture the kind of the temporal, the seasonal variation. So it's annual data, right? You don't have month by month or by week. So if you're trying to, let's say, detect some agricultural changes during, the different seasons, it doesn't capture the information. Although you have some annual variation, also some of the information, some annual embedding might already have some of the context information in there, but still, it's not temporal, like monthly or weekly temporal resolution. So there's some of the limitation that certainly people need to be aware when they're trying to use this data product. But it's the first it's that we don't have this kind of setup embedding like temporal and spatially consistent. So this is the first products that can do that, and a lot of people can use it. I really like the way that you present it, is that you can just use just like set a normal satellite imagery, so you don't have to train your own model. You can just use it directly. So it's very, very easy to use. So it really lower the barrier. But if you're something like you want something very specific, you might still have to train your own model because the spatial and the temporal limitations of the data set. But like you said, going forward, we're going to see basically the gap become smaller and smaller. So I envision in the future that people can give you imagery and then just say, okay, I want to extract vegetation. I want to extract the lake. I want to extract any features that we want to extract. And then you don't have to worry about how to train the model. And you can give any spatial resolution imagery. So for example, I want to extract the agricultural area. You can give a Landsat, you can give a Sentinel, you can give a NAP imagery, you can give air imagery. You will be able to do that for you. But right now, we are not there yet. So you still have to train some model. Although you can use this embedding, but it's tied to the particular resolution. It's tied to the particular time. So if your data is not trained on there, you won't be able to get the result, very accurate result. So there's something that I'm hoping in the future you will be becoming easier. So we can really have some like ChatGPT moment that give me whatever data you want, and then just tell me what you want to extract. I will give it to you without you having to build the model yourself.
Yeah. I feel like we're kind of like in like the GPT-2 phase of like things. Like we're just starting the journey, and like I'm excited for the future. But I think there's just a ton of opportunity still to like, use things like GeoAI or some of the segment anything models to like kind of get you started on the lower level where you say like kind of identify cars and stuff like that. As you built out GeoAI, kind of, how have you seen people use it, and how do you recommend people kind of use this? Because these models are, I think, for the most part, trained on like images like we're looking at, tell me that there's a book back here, or there's a planting background or stuff like that. How do you help people like kind of, get integrated into those things, and then do some of the, I don't want to call it prompting, but, like how do you tell them to like, talk about, tell it what to put into it to pick the right things?
Yeah, I think one of the challenging tasks is to actually create a training data. So the geo package, basically the goal is to make it easier for people to train the model and then use that to do object detection or segmentation or other computer vision tasks. Because we have a lot of other packages, maybe not a lot. For example, PyTorch or TorchGeo or some other package they can use that to do AI and machine learning. But the problem is that not many people really is skillful in using Python to build a model by themselves. So my goal is to actually make it easier that you can focus on more on preparing data, and then you can just select some um, set models that you can just without even worrying about all the architecture, because not everyone know how to do that, and then just get the data. So if you want to do building detection, you just give me the imagery. I mean, you can train the model or you can use some pre-trained model, and then you can use the model that I already trained. But my focus is not to create those pre-trained models, because I don't have those computing resources. I don't have Google and AWS that can train large amount of data, because it needs a lot of GPU. But my goal is to develop the workflow that if you have the resources, you can try it out, you can build all data. But the most time consuming part for me, like in developing those packages, is to find some good sample data and then create some simple training data that I can showcase the application. But I don't have time to create perfect training data. I don't have time to train the perfect model. Otherwise, you'll be spending a lot of time. So my goal is to showcase you can do this, you can do that. But if you want to get really good result, you might need to have some good hardware to be able to train the data and develop all data. Also, in the meantime, I try to showcase how do you get some good training data without having to develop on your own. So you can get, for example, data from our tool, or you can get some open access data to train the model. But it really makes it easy, because I have tried to learn those stuff for a while. It's not very easy. And it took a while for me to actually figure things out. And now, once I figured it out, I want to really make it simplified so that people can use it just with couple lines code without having to go through so many steps. If you have ever trying to use other packages to do machine learning on GeoAI, you most likely open a notebook and then some example. You will maybe import 20 lines of code, just importing all kind of libraries, everything, and then it's not very easy to use. So now with the package GeoAI, you can just import the package and then just pointing to the input data and then select the model that you want and then get the result. So you can get things done pretty much with a couple lines of code. So it's much more simplified. But like I said, it's still work in progress. It's not perfect. I'm just trying to make it easier for myself and other people.
Yeah. But it's one thing that I have as like a goal is like to see if I can actually pull off building my own model at some point, but it's hard because there has to be good enough granular data out there that's you can access, which isn't always the case. And then all the ways to build the models is like that's a whole other thing. But I mean that's kind of been my starting point in playing around with it's been your package. So like I'm still trying to figure those things out. It's like a whole new piece for me. So but at some point it's something I do want to do is like to see, okay, can I actually get all that out there? As you are, I mean, you're putting a tremendous amount of resources out there, obviously the new book. How do you see geospatial education kind of evolving? Because it's I think there's a lot of different ways people are learning. I think there's a lot of different modes that people are using to learn. And it's changed a lot just from, just, kind of in the way that, I mean, I somehow you did the same thing, but kind of just put things out there. People are picking them up and learning them. You have the unique perspective of also being an educator. What do you see as the changes taking place in our education, the way people are learning in school, and then ongoing education?
Yeah, certainly I think there are a couple things right now in geospatial education. The first one I think would be kind of moving away from desktop GS to cloud-based geospatial workflows. And I mean, especially after pandemic, right? We moving from in-classroom teaching to a lot of online teachings. And so during the time, we have looked at some of the cloud computing platform, for example, Google Ascending and the previous Microsoft Printed Computer, AWS, Google, cloud. So there are a lot of these kind of cloud computing programs become more and more available, and also producing a lot of these kind of geospatial data that people can utilize. And you can certainly see that more and more universities right now are kind of also teaching beyond just the traditional desktop GIS, QGIS, ArcGIS. We also teach cloud computing skills. For example, Google's engine is one of those popular tools being taught in classroom. So this one. The second one would be also a lot of more open access, open data initiative. For example, the cloud native geospatial um, uh, initiative that a lot of new, for example, standards protocols are built on all of that. So cloud optimized GeoTIFF, spatial temporal asset catalog, and also GeoParquet, right? So those things have developed very, very quickly during the last couple of years. It makes us actually much easier to teach at the university, because now we can just point into the URL and then can visualize data. We don't have to actually download the data. So enable us as educators to teach students how to actually stream the data on the fly. So I always kind of give this analogy in the classroom. Like, why do we want to use, moving from the desktop to cloud is kind of like decade ago, we are buying the DVD, trying to have a decent computer to be able to watch a Blu-ray or something. But now nobody is really buying those DVD anymore. You're all streaming, doing the streaming, using streaming services, YouTube, Netflix, by trying to watch a movie. I think the trend is similar, very much similar in the geospatial. So we produce a large amount of data, but we don't. Not everyone has the resources to handle those large amount of data. So we certainly need some cloud computing resources. So the second one is like more open access data and also cloud computing resources. And the third one is like open geospatial education. So something that I'm really passionate about is to teach people how to utilize these cloud computing resources and open source to do some interesting applications, so that you don't really need a college degree to do this stuff. If you really have some time and then you have patience, just watch some videos, just like your videos and a lot of other videos. For example, use Java or Spatial Source. Also have a lot of like open education materials available, so anyone can learn. So my goal is to make people more aware of the geospatial technology, and they can use those to make the world a better place, because you can, and when something happens, right, everyone can do something rather than rely on big tech to wait for them, to example, to detect the damaged building or something like that, right? If we all have the skills, everyone can contribute. Just like at the end, everyone can contribute to OpenStreetMap, right? You can just do some delineation, but we still have a long way to go, because even we have all of these, materials, context, people still need some computational resources. So if they don't have a good computer, they won't be able to actually to do that. So I'm hoping that we can have some kind of platform that allow people to utilize this stuff, and also to teach the technology to a wider audience. So for me, I'm teaching in class. Usually the enrollment is pretty small, maybe 10, 15 students. That's all. So for me, I always record my lectures and then just put on YouTube. Anyone can watch. So, and it reaches thousands of people, not in the classroom. So for me, you don't need a college. You don't need to attend a university to learn this stuff. You can learn it just using YouTube or online, as long as you have the time and the patience to learn this stuff. You can certainly make a living out of that if you're good, really good at that.
Yeah, it's I think it's funny because you hit on a lot of things. Like I see the way we manage spatial data, which I think for a long time was taught with desktop and servers, right? You know, you're building those types of workflows. It's not that desktop is going away. I mean, I use QGIS, on a pretty regular basis just to check things out and see it. But the data I'm connecting to is usually in a bucket somewhere. So it's just a different paradigm of like how we do those things. And those skills are definitely in command, or demand, I should say. And I think what you pointed out is that certainly there's, a lot of continuing kind of education in the ways that people are trying to pick these skills up in different forms. I've seen a lot of even job postings that are just looking for like kind of, certifications on learning some of these things and stuff like that. And what's really cool. I think, I mean, you know this just as well as I do, is like, you can kind of put something out there and you just never know where it's going to end up or whose hands it's
Mhm,
going to end up in or what it's going to impact. That's kind of like the fun part about like when I put together like a tutorial. Like I never imagined I could film a video about QGIS and
mhm,
I don't even know that hundreds of thousands of people have watched it, and then it's ended up and helped them in a different way. Like I think it's really cool to see those things get out there and just kind of take on a life of their own. So there's certainly a demand for this type of education. But I mean the points you hit of like, the open data and making it more accessible and easier for people to get their hands on is a huge shift from where it was before. Like,
mhm,
just the downloading workflow or the anything like that, the ability to kind of understand how to interact with the cloud. I think there's still steps to
mhm,
go there to get people more access to those things, and that's something I definitely want to work more on, is that. And then just making people aware of the choices they can choose is like, there's so many things out there, and just kind of helping them do that. Those are really kind of key points. I think are totally in line with what I'm seeing
mhm,
as well, which is cool to see. Um, yeah, how, I mean, kind of what else are you kind of working on at the moment?
mhm.
What other things kind of are you are thinking about or focusing in on?
Yeah, I think so for this summer or for the rest of the year, I'm focusing on um, two packages. GeoAI basically try to help people to do geospatial AI easier using the package. Although right now it has some basic um, object detection, semantic segmentation, change detection, but there's still a lot more things we can do with the package, including to incorporate some more like foundation models and also some large language model functionalities that allow people to do prompting. So there's something I really want to basically incorporate into the package to make it easier for people to do machine learning on geospatial data. So that's one. The other one, I recently created the Animate package. That one is also something I think I'm going to spend more time on. That is to make it easier for people to do 3D visualizations using the package. So basically, you can choose any of the mapping backends, popular Python, JavaScript libraries. You can do that using um, Python and also Animate. Although I already have Leafmap and some other packages, but those things heavily rely on some other open source Python packages. So if something goes wrong, you need to sometimes wait for the maintainer to fix that. So for me, I really want to build from the ground up. So I build directly from, for example, Mapbox or MapLibre or OpenLayer, and then people can directly use that to do a lot of functionality. So also you can add more things to the more plug-in or widget to the map rather than have to rely on other packages. So it's going to be a lightweight, but I'm pretty sure it's going to become more and more powerful once I have time to add more functionality into the eventually. I really hope that it can handle all kind of geospatial data, local data, cloud data hosting in the cloud, LiDAR data, and all kind of geospatial data format. And you can do that all using a Python environment without having to know JavaScript or React or TypeScript. But I have to learn those languages. As I don't know all of them, so I'm gonna spend time to learn all those languages. But to make it easier to integrate the functionality so they can use Python without having to know JavaScript. Yeah, so those are two, I think, packages that I'll be spending a lot of time on for the rest of the year. And so if it turn out very well, I'm also trying to maybe write another book on GeoAI. So basically teach people how you can really use geospatial, kind of like to introduction to GS program, but introduction to GeoAI, that you can use these open source packages and also open data and also open cloud computing to do some cool stuff using just the browser.
Yeah,
Mm,
that's it's no small feat.
mm,
Yeah, it's a lot of work. I mean, I just knowing across, and I'm sure you get this question all the time too, is that, from teaching, you know,
mm,
producing videos, writing the code for these libraries, throw a book onto that. How do
mm,
you kind of balance all of doing all those different things? I mean, that's
mm,
I know the level of effort it takes to kind of
mm,
create content and
mm,
push things out there, and it's always like, it's always impressive, kind of, you're juggling a lot of different pieces. How do you kind of manage all getting all those things kind of done and keeping them all moving at the same time?
Yeah, that's a good question. Certainly, it's something that time management is like it's a challenging one. So, but if you really enjoy doing something, I think you always find time to do it. So for me, when I'm when I have free time, when I'm relaxing, I'm coding because coding for me is relaxing. And so I sacrifice a lot of time. Although I mean, my family complain all the time that you work too much. It's like, why are you working on it? But I also try to have a balance, like spend more time with the family and also trying to produce more stuff. I mean, it helps myself, but also in general, if you have other people, I'm more than happy to do that. So my work hours, I mean, I work at the university daytime, but at night I work from usually from 9 p.m. to maybe 1 a.m., 2 a.m. It depends. But I never go to bed before 12 a.m. So that's just my after my kid go to bed, then I can start working on stuff. And either it's coding or sometimes recording videos at midnight. It's kind of my daily routine. I also work over the weekend. So to me, there's no really shortcut, but you will find time to do it if you really enjoy doing that. So, but at some point I need to take a break, but I think I'm able to take a break.
I think I'm finally glad to like, I'm glad you said like you find coding relaxing, because sometimes I can find writing, for whatever reason, like a complex SQL statement, very like the challenge of solving a puzzle, kind of the aha moments that come along with it are like super rewarding. So it is like for me, it's same thing. It's like kind of this, like, it actually doesn't feel like it's such hard work. It actually feels like you're like solving a puzzle. And that's what I love about it, is kind of getting those little wins along the way. And then, yeah, I mean, it's a ton of effort, but I think you say you kind of, certainly it's a something you can be passionate about. It doesn't feel like it's such an uphill lift of all those different things. But there's so a few people I've ever heard, they're like, oh yeah, coding is like a relaxing activity for me. So I'm glad to hear that you too, because I'm like, I totally feel the same way.
Yeah, another thing that I really enjoy doing is to fix all the GitHub issue people reported. So if you have that report and clean up all the issues, you feel like, oh, that's something that I finally resolve all the issues. Basically, people have some problem, you fix it, and then you move forward. So, so when I have time, I try to go through some report and then try to either fix the existing issue or think about something that I use that is not available, and then trying to create. And then eventually, if you figure it out, right, sometimes some issue looks simple, but it took hours to figure it out. But once you figure it out, it's like, wow, finally I figured it out. So you can spend hours just on sometimes some simple issues. But yeah.
Nice. Yeah, I mean, it's a ton of work, and it's benefited, thousands, tens of thousands, who knows, hundreds of thousands of people. I mean, and that's a really amazing impact. And every time we get to talk, it's I know, I was down there this spring, and we had a good chance to kind of talk and connect then. So it's always fun to catch up and talk a little bit more. And I'm glad we can kind of share this with the world as well, which is good. Yeah, Dr. Wu, thank you again for the time out of your schedule. Appreciate kind of diving into all the different things around Python and SQL, your book, embeddings, everything like that. For people who want to learn from you, if you don't know that Dr. Wu's on YouTube, I'll share a link to his channel in the comments or the description here, depending on where you're watching or listening to that. You're on LinkedIn too, so I'll drop that there. Anything anywhere else? Obviously I'll include a link to the book on. So you can get a copy of that as well. But where else can they kind of find you? Are those the big places?
Be on LinkedIn, YouTube, GitHub. Pretty my life is my daily life live on GitHub. So you can also following some of the open source project that I'm working on. And feel free to reach out. Have any questions? I'm happy to chat. And if you have anything you want to see in those open source projects, feel free to reach out to me or open an issue on GitHub. I think that's the best way to also to contribute to the open source community, is that you ask a question, we fix some things, we make it better. So eventually other people can also benefit from your question and also your bug reporting, feature requests or something like that. I also welcome all the contribution, I mean, in general, to the open source projects. right now it's just myself, but I would love to have more people contributing to those open source projects. So and benefit other people.
Awesome. Well, yeah, thank you again for taking the time, and yeah, I'm sure we'll be talking again soon.
Yeah, of course. Thank you very much, Matt.